Good morning, folks. My name is Alex, and in this episode, we'll talk about Unreal Pixel Streaming in Azure and all of the innovation that is happening in the field right now. So you can find this information about Unreal Pixel Streaming in Azure, how to deploy and how this solution is architected on learn.microsoft.com. We can see that there's a page that is talking about this, and it's talking about architecture and how to deploy Unreal Pixel Streaming in Azure in multiple ways. But before we dive in, I wanted to talk a little bit more about the innovation in general and the pace of innovation. So a great example of the recent mind-blowing innovation is the Las Vegas Sphere project. And what's interesting about this is that it was this U2 concert being held in Las Vegas Sphere recently. This is what the Wired had to say about this, that Las Vegas Sphere makes virtual reality a full body experience. So many different like LED screens and so on, inside, outside. It's quite mind-blowing, the scale of it. And it's also interesting to know that it cost is $2.3 billion for construction of this. And based on some of the reports that you can find on X, formerly Twitter, the cost of advertisement per day is $450,000, and per week it's about $650,000. So while the pricing is quite biting, I guess, but still, this innovation is moving forward, and it's going on fast. So let's come back to Unreal Pixel Streaming in Azure. So just again, as you review the architecture here, you can see, like, for example, this is a good picture here for the multi-region deployment, and you have clients of different kind, maybe a web browser in which you are doing pixel streaming of Unreal apps from Azure. And then this is the architecture described here. So just to make it a little bit more detailed, I drew this representation of the Azure Pixel Streaming deployment. And this is just a single region, single Azure VM scale set that I deployed in a single region. And this is how it looks. So we're basically dealing with 3 different resource groups. So your browser's up at the top. You have basically, you prepackage your Unreal application. This is this resource group right here. And then there's a resource group that gets created as you run the deployment with all the main resources for matchmaking server, as well as for the signaling server, as well as for the Unreal Engine app in it as well. And then in your main resource group, you get the following resources created, such as Azure Traffic Manager, Azure Application Insights, Azure Key Vault, Azure Log Analytics Workspace, as well as an additional Azure Storage account, which contains several containers such as uploads and zips, where your packaged application will be copied, as well as some additional archives, miscellaneous archives to support basically the operation of VMs in Azure Cloud. So just notable that some of the ports, as you're going through installation, some of the ports will be manifested inside of the appropriate Azure network security groups associated with different VMs, or with the VM scale set for what runs Unreal Engine application. So this acronym in the resources names that you will see created, this stands for matchmaking server. And then when you see VMSS, that stands for a VM scale set. And this is under VM scale set. This is where you have your deployment of your Unreal Engine app, as well as the signaling server. The signaling server for WebRTC, which is used by Unreal Pixel Streaming, is called Cirrus. So this is how this is architected, and this is one of the description of the physical deployment that you can see once you deploy Azure Pixel Streaming. And then, before we dive in, I also publish articles on medium.com. So if you're interested in lots of different innovation topics relative to immersive experiences, embodiment of AI, or in general Microsoft Azure Cloud and AI and deploying AI models using MLOps and Kubernetes distributed applications on intelligent edge as well as intelligent cloud, multimodality for generative AI. I have a lot of stuff here for your enjoyment. So if you're interested in checking out my medium.com publications, please feel free. All right, now let's dive deep into the deployment. So first we start with the getting started with the Pixel Streaming in Unreal Engine page on Unreal documentation page. And then we basically, we start preparing our project. We install the plugin, the Pixel Streaming plugin. We can also take a look at the rest of the instructions there. Have some tools installed, which will allow us to prepare our project for local pixel streaming, just to test it initially. This is how it looks. So we have we basically run a signaling service to run this locally. So once you're all prepared for local pixel streaming and then it runs successfully, then you will be in position to start packaging your application for deployment in Azure. So we'll start with, again, checking the plugin, that Pixel Streaming plugin is in place. Here it is. Then after this, you also want to make sure that some of the project settings are set up, including the touch controls, enablement, as well as some other settings per documentation. And then you will be interested in packaging your application for Windows. This is how that final result looks like when you launch the packaging, and it creates this Windows folder for you. And it contains multiple subfolders as well as different files in your exe executable for your application. So we're using the first-person template for this presentation. Yeah, so let's start packaging our application. If the packaging is successful, then you will have your result produced. You see the build has been successful, and then you have those files produced. If you have any issues with the packaging, then you may want to see the version of the Visual Studio which is used, and then check the project settings for toolchain, assignment of a proper compiler and proper Visual Studio version. Once you packaged your application, then you want to package and zip the contents of the Windows folder into a zip archive, and this is what we're going to take forward and upload into Azure Blob Storage as we deploy this first-person application in Azure for Unreal Pixel Streaming. Here's my build.zip. Once all of this is done, then let's take a look at the process of deploying Unreal Pixel Streaming in Azure. So it's suggested that you use specific types of families of VMs, and C and NV in general, in my knowledge, work well. You want to be cognizant of the fact that in your subscription you may not have a quota provision, so you want to take care of that if necessary. So I have 18 cores for NV family of VM available for me, so I can move forward and create. Basically, I created two resource groups. One is called GPU and another one is called GPU support. So in GPU support, I have a dedicated Azure Blob Storage account in which I uploaded my build zip file for firstperson.zip. This is how it looks like. It's right here. Because later on, I'm going to reference this blob storage archive as part of deployment. So again, this is my firstperson.zip, and I have all the files in place for a successful deployment, including my executable and some other miscellaneous files. All right. Next up, I'll be in my main resource group, which is supposed to be empty before the beginning of the deployment, which is called GPU in my case. And I'm searching for a marketplace item for Azure Pixel Streaming. Here it is. Let's move ahead and start deploying it. Select Unreal Pixel Streaming, and then you will choose the region of your deployment. And then because again I had a quota for NV family of VMs, I'm going to use that. So I'll select that NV machine with the GPU and 18 cores. And then for the matchmaker VM size, I'm going to select the general purpose VM, which is less powerful, but just enough for the job. It's the D family. Then after this, you select and point your deployment to the zip file inside of your storage account, which we uploaded our firstperson.zip file, packaged application. And you specify the admin username and password as necessary for connecting to VMs if will be required. Then I will select the region of deployment, just one for this presentation, West US 2. Select the number of GPU VMs to 1. And then there are a couple of interesting settings relative to the spot discount and auto scaling, which can help you save money with your deployment depending on the criticality of your deployment. But I'm gonna go with the default. Then the resolution and FPS settings for your Pixel Streaming, and then security. Keeping this as default, and then networking hints on the port numbers that will be configured for you as a part of this marketplace deployment of Unreal Pixel Streaming in Azure. I'm using the Stun server, which is default. And then finally, not interested in deploying the admin dashboard. In fact, this is a very handy feature. So please consider if necessary, and then we're ready to create the deployment. Once we create a deployment, it's going to run for several minutes. And in my case, it's going to propagate all of the necessary resources per the diagram that we discussed earlier in my GPU resource group, and it's going to create another resource group, brand new resource group with all of the VMs for matchmaking service, as well as the VM skill set for the Unreal application, as well as the signaling service, which is the Cirrus service. Yeah, here's my main resource group GPU, and then it has those resources created as necessary, including Key Vault, App Insights, Log Analytics Workspace, Traffic Manager, which allows us per diagram, which allows us to reroute traffic to if you have multiple deployed VM skill sets in different regions. If you take a URL of the Traffic Manager and launch it in the web browser, then it says all Cirrus servers are in use, retrying in one. So something apparently is not completely set up. We'll just look into this next. So we'll go into this. This is those two resource group. We'll go into the one that has the VM skill set. And because ultimately the matchmaker from Traffic Manager, by means of matchmaker, we get access to basically get rerouted to the VM skill set with specific GPU enabled VM that runs your Unreal application. So we can actually look it up under virtual machine skill set. And then under instances, we can see the specific VM SKU that we installed and deployed, which is the NV VM. And then if you take a public IP address of this VM, we can test if we are able to pixel stream directly through that VM without using Matchmaker and without going through Traffic Manager. So it says disconnected streamer is not connected. So we want to make sure that the streaming, the signaling server is running. And for that purpose, just to make sure that this configuration is in place, we can actually go to networking and try to connect through RDP. So by default, RDP port, because of the standard security considerations, is not enabled. But just to, again, understand the mechanics of that deployment, we can enable 3389 RDP and be able to log in and RDP into that VM with the credentials that we specified at the time of deployment. Here's that inbound rule that we added, and it's going to be deleted over time because, again, of security considerations. But for us, we will RDP into the VM at this point after we enabled the RDP port. And then you can see this in the root of the C under Unreal_1, we have two subfolders, scripts and the Windows No Editor. So Windows No Editor, you saw that it contains our application. In scripts, we have start MMS, matchmaking server, and start VMSS, which takes care of the starting of the signaling server. If I open this in PowerShell, the start VMSS, then you can see this is what it takes to start the signaling server, and by default this is the name of the application, which is not corresponding to my name. So my name of my application is first person, so I'm changing this. And then typically this runs on the task schedule, and when you launch it, when you launch the VM, it's supposed to take care of the starting of this, but just for the sake of this quick presentation, we'll just run this script, the PowerShell script, directly from the VM to make sure that the Cirrus server has been started successfully. So once you run it, then you will see the pop-up of the Cirrus on the screen. And at this point, we expect that the signaling server is running successfully on the inside of the VM. So if we try again and take a look at the browser on the outside of this VM, we can see that right now we are able to connect and pixel stream our application through the infrastructure that we deployed in Azure for Unreal Pixel Streaming. And we can give it a try very quickly, take a look how it plays through the web browser. And then at this point, again, knowing that we are successfully able to pixel stream, we can also try to navigate back to the Traffic Manager in the main resource group, and then grabbing that URL again of the Traffic Manager, and then waiting for a little bit just for the reconnection to take place. And then once through Matchmaker, the Traffic Manager, and we discover that there is a Cirrus server running, then we are able to stream this application same way, but just now this time we accessing this through Traffic Manager URL.